All right, welcome back to my channel, everyone. I'm going to be doing the first problem with you, and you can follow along, and then you can try the second one yourself. So part A asks you to measure and label the incident angle. Now remember, the incident angle is always the angle between the normal line and the incident ray. So it's this angle right here, right? So I'm going to take my protractor. And I think it's honestly a little easier if I line it up along the normal line here, just so I don't have to do any math. I'm going to take a straight edge. I'm going to take my schedule here, just line it up along this, and it points right to the 25-degree mark. So here's our 20, here's 25. So it points right along to that 25 degrees mark. I'm going to remove this, and my incident angle, theta incident, is equal to 25 degrees. So that's part A. Part B, using Snell's law, find the angle of refraction. Okay, show all work on the right side of the paper. So we're going to be using Snell's law. Snell's law in the slides is stated as N1 sine theta incident is equal to N2 sine theta refracted. So my first index is error. So I'm going to put 1 here. Sine of my incident angle was 25 degrees. My second index is glass, so 1.52. And I have no idea what the sine of my refracted angle is. So 1 times sine of 25 degrees is just sine of 25 degrees. Just gonna rewrite it so that it looks a little nicer to look at. And in order to get this by itself, I want to divide by 1.52 on both sides. So my sine theta refracted is equal to the sine of 25 divided by 1.52. Okay? So all of that, when I put it into the calculator, I'm going to hit my fraction button. So the sine 25 divided by 1.52 is 0.278. Okay? Make sure to check if it's in degrees mode. So now if I want to find the angle of this value, we're going to take the inverse sine of 0.278. So to get to the inverse sine, I find the trig menu. So this is trig over here. On your calculator, it may look different. And once I get to the trig menu, I'm going to scroll down and look for sine inverse. It's number 4. Okay, and then 0.278. Looks like the angle is 16.14 degrees. So finally, use a protractor to draw the refracted ray. So this Snell's law tells me that the refracted ray comes out on this side 16.14 degrees from the normal line. So I'm going to turn my paper, make the normal line along the protractor like this. I'm going to find 16 degrees. So 16 degrees, this is 15 degrees, right? So that means 16 degrees is going to be the one right next to it. Make a little mark here. I'm going to draw a straight line and line my protractor up with that little mark I made. It's going to come out like this, and I'm just going to draw it so that it ends at the end of my picture here. So if you turn it back around, look at how it bends towards the normal line. That's how we know we're right, because we're going from less dense to more dense. So this here is our angle of refraction. All right, hope that was helpful.